Hey guys, let's look at this multiple choice review, number 4. These questions were all no calculator. The ones that you selected I circled. So number 2, if we look at number 2, that's going to be another one of those definition of the derivative questions. So the definition of the derivative, the limit as h goes to 0, f of x plus h minus f of x over h. So we need to find out what the function is. The function is the natural log. The x value for which we're going to evaluate that function is 2. So we're trying to take the derivative of the natural log and evaluate it when x is equal to 2. The derivative of the natural log, dx of the natural log of x, is 1 over x. If we're evaluating it at 2, 1 over 2 is 1/2. Okay, so y prime of an exponential function is e to whatever's up there times the derivative of whatever's up there. So times negative 2x, I guess. The second derivative, we're going to need to use the product rule. The second derivative, the derivative of the first times the second plus the first times the derivative of the second. And now we're evaluating this at x is equal to 0. So if we're plugging in a 0 wherever we see an x, this part is going to go to 0. Plug in a 0 here, we get negative 2 times e to the 0, which is just negative 2. Okay. In order to have either a local maximum or a local minimum, the first derivative has to be equal to 0. The first derivative also has to have a sign change. So we need to have a sign change and the first derivative be equal to 0. Well, there are 3 places when the first derivative here is going to be equal to 0. Those 3 places are x is equal to 0, negative 1, and positive 4. So those are the 3 places when the first derivative will equal 0. But remember our days in pre-calculus that if we had a root with an even multiplicity, then we had a turn. If we had a root with an odd multiplicity, then it was either like a twist or even something that went straight through, but we had a sign change. So even, no sign change. Odd, sign change. Because the multiplicity of 0 is an even multiplicity, then we're not going to have a sign change at 0. We are going to have a sign change at negative 1 because it had an odd multiplicity. So this one we're going to have a sign change. Here, even multiplicity, so no sign change. So the only place where I have a relative maximum or a minimum is at negative 1. Alright, to have a maximum, we need to have our first derivative equal to 0. So let's find the x value of that. Our first derivative, the derivative of the first times the second plus the first times the derivative of the second. If we look, both of these have an e to the negative x, so let's factor out that e to the negative x, and we're left with 1 minus x. So the value of x for which the first derivative will be equal to 0 is 1, because this will never equal 0. So we only have this one place where our first derivative will be equal to 0. That's where our maximum lives. It's not the value of the maximum. So what we have to do is take that x value and evaluate the function there. Well, 1 times e to the negative 1 is 1 over e. Okay, so we know that our initial condition, or our starting value, is 8, 10. So when x was equal to 8, our position was 10. So we're going to start here, and we want to go back to 5. So let's find the area of this right triangle, which has a base of 2 and a height of 4. So the area of that right triangle will be 4. The area of this right triangle has a base of 1 and a height of 2. So the area of that right triangle, using 1/2 base times height, will be 1. So our initial condition was we started at 10. Now remember that if we're taking our definite integral and our lower bound is greater than our upper bound, so if we're going from 8 to 5, then the areas, the signs of those areas are opposite. So it's not going to be a negative 4. Because we're going this way, this will be plus 4. And even though this is above the x-axis, because we're going from right to left, minus 1. 10 plus 4 minus 1 is 13. I think I'm going to need a little bit of scrap room over here. I try to tell her in a song, but she don't hear me. I try to write her in a note, she wouldn't read it. Sometimes gotta sit her down, right into her eyes, say I love you. Sorry, let me just copy down that problem. Pi over 4 to pi over 2 of the sine cubed x cosine x dx. Okay, so this is a classic example of when we're going to have to use u substitution. So the first thing we want to do is decide what we're going to call u. I'm going to take what's being cubed and call that u. So now let's rewrite this definite integral as u to the third. And then the derivative of u was already there, so all we have to add in is du. We also want to change our limits of integration. So if we change our limits of integration, our lower limit of integration was pi over 4. The sine of pi over 4, which we remember from the unit circle, is square root of 2 over 2. If u is equal to the sine of pi over 2, the y value of that point on the unit circle is 1. So now, if we take the antiderivative of u cubed, we get u to the 4th over 4, and we're evaluating this from the square root of 2 over 2 to 1. If I plug in 1 for u, 1 over 4 minus the square root of 2 over 2 to the 4th, the square root of 2 raised to the 4th, if I thought about that being multiplied by itself, we get 2 times 2, 4, over 2 to the 4th is 16, and this is all over 4. So let's simplify this a little bit by multiplying by reciprocals. So we have 1/4 minus 1 over 16. We need to get a common denominator in order to do that. Let's get a common denominator of 4. So we have 4 minus 1 over 16, which is 3 over 16. So hopefully that's an answer over here. It is 3 over 16. Here's another case where we're going to have to use a u substitution. So let's take, I don't know what just happened there, like wrist hit the record button. So let's take this and call it u. U is equal to 3 minus e to the x. Du is equal to negative e to the x. So let's rewrite this as 1 over u squared du, except we have to take into account this negative sign, so negative 1 over u squared du. And we need to change our limits of integration. So 3 minus e to the 0, 3 minus 1 is 2, 3 minus e to the first is 3 minus e. The antiderivative of 1 over u squared, if we think about that as u to the negative 2, let's add 1 to it. So we get u to the negative 1 over negative 1. So we have negative 1 over u from 2 to 3 minus e. And don't forget about this negative sign here. So these are going to actually cancel out. Now let's plug in our limits of integration. So 1 over 3 minus e minus 1 over 2. Let's get a common denominator. 3 minus e over 3 minus e, 2 over 2. So we get 2 minus 3 plus e over 2 times 3 minus e and we look at our answers, none of those were our correct answer. Alright, so we'll talk about these in class on Wednesday. We're also going to do a multiple choice with calculator.